We are the MU 3D Printing Club. Most clubs on campus are competition focused, while we are more research and project focused. A lot of people will come to us and throw out ideas, throw out concepts, and we figure out a way to materialize those ideas and create a project solution. We form a team and ultimately deliver some type of product to solve the initial problem.
During the process of research, we found that there's kind of two main 3D printed prosthetics right now. There's the mechanical hand and there's the electronic hand. And the mechanical hand works by bending your elbow, and that pulls tendons tight, grabbing an object. There's kind of inherent limitations with that design because as you're extending your arm and closing the hand, if you want to bring something towards you, you're dropping it. And we felt like in order to really help somebody, we want to do an electronic hand that we can actually use somebody's natural musculature to grab and manipulate objects. So originally, we actually reached out to a charity in India called Road to Seva. And at this charity, there's a doctor named Dr. Daya, and he was our main point of contact for the whole project.
So I kind of found three areas of interest that I needed to work on. Found a team of people that I wanted to tackle each of those areas.
My primary involvement with the code was I focused on taking the hardware and the electronics that was sort of built. So in other words, we could take a user whose electrical impulses would be sent through the arm. We can actually make the hand close and respond accordingly.
I'm working on designing an EMG sensor just for our prosthetic that'll integrate better, but also just kind of make it overall cheaper and go better with like what we want in our design.
I joined thinking I was going to focus on programming, but what I've ended up doing is a lot of embedded electronics work.
The back cover, which is one of the main components, working on the organization of that to better fit all the components in a more compact, secure, and safe way. Slow down, you got to figure everything out. Really rewarding once you get the last pieces put together and you turn the hand on and you hook it up to your arm and it actually opens and closes.
It's not even just a prototype, it's actually basically a product that we're actually sending to people in India, real people who really need this.
How ours is different is ours does have a battery in it. And I haven't seen that in a lot of other prosthetics, so this makes it very modular, very easy to use. You can plug it in with a USB port. So I think that is definitely an area of impact for the charity we're working with. It'll make it easy for them.
Other clubs in other regions could work on it and help make prosthetics for their community or elsewhere.
We are offered to really any student that's interested in working with our club, or if they just have an interest in 3D printing in general. Over time, we've developed incredible things and worked through a lot of challenges to bring the club to where it is today.
We are students, and we have a lot of stuff on our plate. This isn't the only club that a lot of us are in. And also, there's no class teaching you how to do the electronics design, how to do the specific coding you're doing, how to do the embedded chip programming, how to do the 3D printing. A lot of this is so open-ended, and figuring out just what direction to go in, the impact alone that one hand will have might not be huge, but if we can learn from that first hand and improve a lot on the second and then get to a point where we can turn them out very quickly, I think that will be where our 3D impact is.